Yes, sir. We see, sir.
Okay, just I will come. I will also come there. Yes, many of you are there, but right now the equation is different. What you have to do it, you have to change the equation. Change the equation in the bottom, change the values of A, B there, and you can check whether you are getting the same 6 iterations there. Okay, all you can cross check. I think none of you changed there. Still, I'm yeah. Some yes, different. Yes, you change the different. Change the equation. I want to see who is completing here. Still none of you changed. You have to write the equation. What the equation you have to write it there? I will show you. Just a minute. X cube minus 9x plus 1. X cube minus 9x plus 1. That you have to write it there. Still I'm not getting any correct graph here. None of you completing it correct. None of you change that equation. And you have to change the values of AB as a 2, 3 there on that window. All of you are taking whatever the default equation and default values are there.
So can you repeat the equation, please?
X
Done,
cube
sir.
minus 9x plus 1. X
Sir,
cube.
done. Sir,
Done.
done.
But I'm not able to see who completed here.
Sir,
Yes,
Satyam Anand.
Satyam. Just a minute. Satyam. Okay. Just I will check it. Whether you've done it. Why it is taking too much time? No, Satyam. Still I'm seeing your.
We are just supposed to change the equation.
Yes. X cube minus 9x plus 1 you
Sir,
taken.
I have
Yes,
done
yes,
it.
correct. You've done that. Okay. But
Yes,
the
sir.
graph is looking like that only. Okay, many of you are completed and you put
Yes,
interval
sir.
2, 3. Just take the iteration up to 10. This slider. You have to take this slider up to end. Satyam.
Okay, sir. I'm doing it.
Okay, so we can just I want to
Sir,
see.
done.
Uh, just we have to
Sir,
check.
done.
Okay, many of you are saying done. Just I will check.
Excuse me, sir.
Who completed 10 iterations?
69.
Okay, here is 10.
Need, sir.
Number 6 is there.
Sir.
Just 1 minute. Just 1 minute. So here, this is the, if you say this is the initial iteration x1, x2, x3, x4, x5, x6. So you will observe here, if you take this x6 or this as x6, 2.94 or 2.9375. That is the answer that we are giving after 6th iteration. Okay, so if someone writes 2.9375 or someone writes 2.94, both are considered it as correct. Okay, is it clear?
Yes, sir. Got it. Yes,
Okay,
sir.
okay, so this is the way you have to write the table in the exam also.
Excuse me, sir.
Yes,
Sir, I am unable to make any change in the GeoGebra. When I am changing the value from 6x, which is already given,
first
to
of
9.
all, you have to write the equation here in the bottom input window here. You see in input window there, or no, you are in applet right now. Sorry, you are in that activity part. So in activity part here you have to write the equation. Here only you have to change the equation.
There only when I am changing, no, sir. Like
Huh?
it is already written 6x plus 2. When I am changing 6 to 9 and moving to change 2 as
First,
1, then
first of all, delete everything. Delete everything. Backspace. X cap 3. Okay, upper cap 3. Are you getting? Just type X. Shift 6 there. Shift and 6 so that you get cap. X cap 3 minus 9x plus 1. That's one. Enter. Got it?
yes, sir, got it.
Okay. and then you can change the values of a and b also. And if you want to show the intervals, that also it showing in the straight lines there if you click here. But it will show you that how interval becoming smaller and smaller. So here maximum, see in the final exam, maximum if it is a bisection method, yeah, you have the 6 to 8 iteration. But for other methods you have less than 5 iterations, that is always asked, because examiner doesn't want to check whether you can do 10 or 20 iteration. He want to check whether you are understood the procedure or not. Okay, any doubt in the bisection? We are going to do
Sir, one more problem, sir. Sir, I am unable to write x cube.
I told you na,
Yes, you told,
what you have
sir.
to do, you have to write like this. Just a minute. You have to write first type x, then cap 3 minus 9x plus 1. So this
This
cap,
carefully I have written.
you have to, yes, cap means x cube na. For this you have to press the two buttons at the same time,
Yes,
shift.
this I have already written, sir.
So हो गया ना, फिर एंटर करने के बाद x cube minus 9x plus 1 ही आएगा उधर. हो गया नहीं हुआ? Okay, one more important thing, with the help of this activity now, whatever the activity, if you log into the GeoGebra, okay, if you log into the GeoGebra and you've done this activity, what will happen? This activity is always there with you on GeoGebra, or even though if you are not able to get it, what you can do it on GeoGebra, you can search the activity and just you type bisection method, you will get this activity there, where you can change this equation at any time. Okay, actually this activity is always with you if you log in with your Google account or you sign in there. If without sign in, if you done this, then it will not be with you. Then you have to search them. You can put any equation here, any values where the f of a changes its sign, and then you get the iterations there. Okay, so all examples you can solve with this activity there. Yes, someone is on the chat there. Let I check. Yes, obviously we are going to do more questions, but I'm going to do it, I will do the mixed question, or you want right now only? I want to do all the three methods together and then mixed questions, or if you want right now, then also we can do bisection first, one more example. Okay.
Mixed.
Hmm? Mix questions then. Okay, that's better. We'll do the questions on bisection, regular, falsi, and Newton-Raphson together then. Okay. So let me move there. Just I will check how many of you completed this activity. Okay, majority of you completed here. Okay. Swapni, yeah. Okay. Just who is Dipansh? Dipansh, you are not able to do it.
Sir, actually, I'm logged in my phone now, so there's a sort of
There's a
hang.
problem. Yeah, correct. I already told you that by phone typing is difficult. Okay, it's on laptop or desktop. It's you can do it properly.
Sir, will you please check mine is correct or not? Hafiz Umar Abdullah.
Where is your now?
If you scroll up, then you can see.
Which one?
Hafiz Umar Abdullah. A bit, थोड़ा सा और scroll up कीजिए sir. Yes sir, this one.
Yes, you've done it. X cube minus 9x plus 1, 2, 2, 3. That's correct now. Only if you want more iteration, just move this slider. Move this slider, you get n equal to 10. 10 iterations you can see. It's correct there. Okay, majority of you here is some, okay, graph is not there. Who is 55? Okay, I will check it later on because this will be always with me now. So I can check your graphs later on also. Okay, so that's for the bisection here. Move to the second method now. Let me move to the second method, regular falsi. Yes, three methods together have the 5 marks weightage. Correct, Sanchit. Okay. bisection, regular false, and Newton-Raphson together have the 5 marks. Actually, this topic is this chapter is a lengthy chapter, but simple topic. This is a simple topic. Weightage is 22 marks. Total entire chapter, entire topic have the 22. But this first article, bisection, regular falsi, and Newton-Raphson together have the 5 marks weightage. Okay, the method 2 now. It's a regular falsi. This this method also works on the similar principle of bisection only, that we are going to reduce the interval to get the root there. For this, the method works like this. Suppose we have 2 points. Say, just this is a, I will take a f of a, that is the first point, and let I take second point as a b f of b, b f of b. Now what is f of a? F of a is greater than 0, that should be, and f of b is less than 0. So already I said that f of a and f of b should have the opposite sign. As f of a and f of b have the opposite sign, the root is in between there. This is actually the main root. This is x star. X star is a root of that fx. Okay, x star is main correct root of that fx. Now to get approximation, actually to reduce the interval, in bisection method we divide the interval in 2 parts and we go on reducing it. Okay, that is the simplest way to reduce the interval. But in regular falsi method or method of false position, uh, we are taking here a chord joining the point AB. So if you see, the AB is a chord there, it is a drawn. Okay, and we'll find the equation of that chord AB. What is the to get the equation of AB? We have the 2 points there, A f of A and B f of B. What is the equation of a line passing through the 2 given points? So it is y minus y1 upon y2 minus y1 is equal to, sorry, my mistake. It is actually I written, yes, what the mistake I done? Y, this is the values of y, na? Y minus y1, y minus f of a upon y2 minus y1, f of b minus f of a is equal to x minus x1 upon x2 minus x1. Another important thing, we want the point of this straight line AB which was on x-axis. We want this point x2, which is actually the point on x-axis of the line segment AB or that chord AB. To get that point on x-axis, what should be? Y should be the 0 there. Y is equal to 0. Yeah. So just replace y equal to 0, this y equal to 0, and simplify. We get a simplified answer this way. That is x equal to a f of b minus b f of a upon f of b minus f of a. So this is the formula you can remember, just like we remember the formula for bisection. Bisection formula is a plus b upon 2. So the formula for regular falsi is a f of b minus b f of a upon f of b minus f of a. Actually, this formula is derived from this. Okay, so if you simplify this equation, you get this formula. Is it clear?
Yes, sir.
Okay, so only formula is different. With this formula, we calculate x1. Sorry, x2 now, because already we say here is x0, x1. Otherwise, you can say if you say a, b, then it is x1. Now, depending on sign of f of x1, in this case, f of x2 is a negative. This is also a negative. So as it is negative, the root lies between a and x2 now. A and x2. Again, it is reduced, then it comes x3, x1, and we are moving towards the root there. So it is again iterative method. It is just similar to the bisection only. Instead of bisection formula, we have to use the regular falsi formula only. Okay, our method of false position. So it is name is given as a method of false position because we are taking that position as a root, and we are moving to the iterations there only. Sorry, correct root there. So here is a question. Find a real root of x cube minus 2x minus 5 equal to 0 by the method of false position, correct to 3 decimal places between 2 and 3. Now, what is the difference between that previous and this question? First of all, the method, that is a bisection example. This is the false position method. But other important differences, that differences are the stopping criteria. The stopping criteria in this case is not given as the number of iterations. We are not given do the n is equal to 10 or n is equal to 5. That is, do the 5 iterations, that is not given, or do the 10 iteration, that is not given. So here it is given, it is correct up to 3 decimal places. So we have to do the calculation up to correct up to 3 decimal places. So you can keep the 3 decimal places from the beginning also, or someone have the habit of writing 4-5 decimals continuously, that is also okay. What happens, your answer will be approximately correct. You may have small errors here and there, that is always considered, okay. So let I show you this question on page 29 of a PDF there first. This is a method of false position, the same thing that is there. So this is the way we are going to do it. So we are given n is equal to 1, a is 2, b is 3. Now here we are not interested only in sign, we are interested in their values also. So what we have to do it, when we have to solve it by false position, first of all we have to find the roots of this equation, x cube minus 2x minus 5. F of 2, you have to write the value, don't write only it is negative and positive. So f of 2 is a minus 1, f of 3 is a 16. And here we have the formula then. This is AB. AB is are 2 and 3. A is 2, B is 3, f of A is this, f of B is that. You have to replace in this formula now, all these values. So like A f of B minus B f of A upon f of B minus f of A. With a calculator, you can compute here. Right now, I done a calculation with 4 decimals, but you can keep with the 3 decimals also, or your choice. You can write whatever the number of decimals you want, but generally 4 decimals are enough. Okay. So f of x1 is calculated then. This value you would replace in this fx, and then you get this f of x1. This is f of x1 value. This x1 is replaced in fx. This f of it is similar to the bisection. Only the difference is we are not writing negative and positive only. We are writing its complete value along with their sign. Okay, means sign and its magnitude both are important here. And now obviously f of x1 is negative, so what should be the interval in which the root lies there? You already observe f of a is negative, f of x1 is also negative. So this a should be replaced. A should be replaced by x1. Look at this, x1 text here. Now the new root lies in this interval. So again, this f of x, this value is taken here. F of a is negative, f of b is already 16. Again, x2 is calculated. X2 again still comes negative. So it's continued. It's continued there. Throughout it is coming negative. So throughout it is coming negative. So throughout the a only changing, because a is itself negative and f of xn's are also coming negative. So as they are coming f of xn negative, a is a negative. So a is replaced by xn. Suppose f of xn's are positive. The f of xn's are positive and f of b is positive. Then that time this b is replaced there. So it depends on which values is positive and negative depending on the replacement happens there. So it is just calculative. I will say it is not a difficult, it's a calculative there. Any doubt? Is there any doubt here?
Sir, when we have
Sir,
this,
can we note it down, please?
This is already with you, I shared this PDF with you.
Sir,
How many times we'll do it?
Sir, I only didn't get the formula of xn.
Formula of xn that you have to by heart it. Already I told you how it is derived, but derivation is not coming in the exam. Derivation is simple.
Sir, just for once, can you please repeat the clue for the derivation?
Okay, but actually it is not required. I already told you. still if you
So
want, yeah.
in this process, how many iterations do we have to take? Because it's not
Here
mentioned.
it is written correct up to 3 decimal places. So till that 3 decimals start repeating, you observed here, this is x1. First 3 decimals are here 0.58. So they are not, only first decimal is same. Okay. So when all the 3 decimals start repeating, then you have to stop. So 00 is same. 08 is same. Now 2 iterations start, 2 decimals are same, but third decimal is different. Okay. So now still only one decimal, 093, 094 and 094. So 3 decimals, correct up to 3 decimal. So 3 decimals are repeating, then stop iteration. So here after 7th stage, correct up to 3 decimal is written. Some of you may got this answer in 5 iteration also, provided you done roundup or something. Okay, if you write from the beginning only 3 decimals along with roundup, then also it can happen your iterations can be lesser or greater, but the answer is near about same. Means if my answer is a 2.94 or 2.094, your answer can be 2.093 or 2.091. That is okay. Your answer cannot be 2.08. Okay, like that. Clear? Is it clear?
Yes, sir. Clear.
So yes.
Now some of you are interested still in the proof. So instead of taking the proof here, I will take on that PPT only again. Of the proof, if you observe how bisection works first. Bisection takes, this is a, just a minute. Bisection says, suppose this is the point A, this is the point A, this is the point B. Bisection directly divides this interval as a plus b upon 2. It comes to the middle, and then we check whether f of x1 is positive or negative, and then either we go to this part or that part of the interval. Okay, so this is just, we reduce the search interval by half and we continued there. That is the bisection. But in false position, to reduce the interval, we use the secant method. That is, we draw here that chord AB, okay, or secant AB there. So this AB intersects the x-axis at some point, and that is considered as approximate value. That is a considered as iteration formula. Now to get this formula for x2, first we want the equation of the line AB. To get the equation of line AB, suppose the coordinates of the point A are a comma f of A, and the coordinates of point B are b comma f of B. Okay, now we want the equation of a line passing through these points A f A and B f of B, and we get that equation as y minus y1. What is y1 here? F of A upon y2 minus y1 is equal to x minus x1 upon x2 minus x1. So this is the equation of a two-point formula equation of a line. Okay, clear? Now we are not interested only in the equation of line. We want the point x2 there. To get a point x2,
Yes, sir. I got it, sir.
yes, to get a point x2, we should put that y equal to 0 there. Replace y by 0. And now if you replace y by 0 and simplify this equation, you get this formula, I'm saying. Okay. Already, Hanit,
I got it, sir.
okay, got it, no? Good. Okay. So that about a formula, but derivations are not coming in the exam, I'm saying. It is you have to use the formula to get the answers there. Now what we'll do it, we are going to do this question again on the GeoGebra. So let I share this link also on the your chat window. Remember, the GeoGebra is not a part of our curriculum. It is just for it is I use as a teaching aid for it is just for your more understanding, or there are already default apps are there where you can get these solutions to understand in more better way. So I'm using GeoGebra here, but it's not part of your curriculum. So just click on that link and you can start your work. I want the same question, whatever we completed right now. That question only I want. What happened? Okay, which question you have to write? You have to change the equation actually there. I think. What's the equation? We have to take it.
X cube minus 2x minus
Minus 2x
5.
minus 5, correct. X cube minus 2x minus 5. So who completed there? I think many of you done that, but I think
Sir, are you talking about the new by regular Falsi method?
yes, regular Falsi method.
Sir, there is no input tab there.
Yes,
Okay, there
sir.
is
No
no
So
input
we
input.
tab.
cannot write it.
So we are not able to put any values.
Okay. So my mistake. I think I will just check there. Just check 1 minute.
Sir, is the instructions there in English, because in mine they are showing in German.
Same as here.
Okay.
Same here, sir.
Same as with us.
Probably I taken then wrong activity then. Just I have to.
In my computer, it is not showing anything else. Only that previous bisection method is being shown.
No, bisection method can't. Okay, so here is no input bar, or as I think all of you are saying. But okay, just 1 minute then. Mm, just 1 minute. So there are. This one I may be taken there. So what is the? Okay, there is one default. Okay, so whatever the activity I given, it is only for that particular example there. So it is taken for the function. The function. Where is that function? X square minus 2. Fx is x square minus 2. The interval is given
Yes,
minus
sir.
0.5 to 2. Okay,
Yes, sir.
minus 0.5 to 2. And this second started here is x3, then and it is continued. So number of iteration, just you can check. Sorry, just you can check how many n's are there, and you will observe that every time this x3, x4, x5, and you are moving to the exact root is here somewhere. Okay, that way. So okay, what I will do it. I will check. There is other way then. Okay, if you are not, but here is graphical. You can see. Otherwise, what you can do it. There is one more way. You can go to.
Sir, actually in this one we can drag the points
Yes,
x2, x1.
correct.
We can drag them, sir.
Okay, if I have if I get some better activity there, I will show you in the next time. Means for this regular Falsi. But otherwise, if you want to see this table, actually table solution, what you can do it, just type A to Z maths, A to Z maths there. When you type A to Z maths, you click on numerical method. Okay, click on numerical method. Here is a bisection method also. Everything is there actually. And in numerical methods, false position method, you will get it here. Okay, here bisection method is also there, false position is there, iteration methods are there. Okay, all methods are here, many of the things. So what you have to do it, just click on false position method. False position method. I think some advertisements are there on this site, but okay, so better. This is a false position method. Now what you have to do it, just you have to type your equation here. You have to put the interval values a b there, and it shows you a table. Just if you click on the table, just you click on find, it gives you the table like this, or it gives you the detail there. At the end it gives you a table. Okay, this is a step-by-step solution it gives you. So it's advertisements are there mainly. That is a problem on this site, because this is not a students mainly. You should understand the procedure mainly. Actually, this site is of no use to you because it gives you a solution directly. It is only to cross check. If you want that, you can use. GeoGebra is okay because you can see what is happening with the graphs also. That is main part, main intention is there. Otherwise here you get only. This is the answer. You get the table. Is it clear here? This one. This way you get a solution there at the end.
Sir, excuse me.
Yes.
In the GeoGebra account which I was using,
Huh?
only bisection method is still shown on the screen. How to take this new one?
You have to click
Regula.
on that new link. This link I shared on the. If you click on the new link, you get a new one. Actually, this is not from GeoGebra now. Whatever the link is shared, it is of no use. Don't use that also, because that is for only one particular example. So no need to go to that second activity again. Are you getting? So instead, I shown here this way. This is actually, but they have the different notations here, x0, x1. So no worries there. So here replacement is done like this. X0 is replaced by x2. Okay, like that. They are doing there. Okay. So where you should focus now, the focus should be here, that in the examination you have to do like this, or do like this. Now one last question that I will show you only because it is a calculative and you should do a calculation today. This PDF is with you, so go through it and do it. Do these three examples only for today. If you do these three examples, later on there is no need to do any example also, because you will understand everything there. Okay, of bisection and regular falsi. So here the second question is find the root of x e raised to x equal to cos x using regular falsi method. Okay, x e raised to x x e raised to x equal to cos x using regular falsi. Now the difference between the previous two question and this question is this equation is known as a transcendental equation. Okay, previous two questions are about algebraic equation. This is a transcendental equation. Now for transcendental equation, the most important thing that you should remember, this is a very important note, you will make mistakes otherwise in the exam, that you have to use only Radian mode of your calculator. If you not change the mode of your calculator and you do the calculation in degree mode, okay, then your entire calculation goes wrong there. So first change the mode of a calculator to the radian only, and then only you will able to check these values. Now cos 0 is 1, and this is also 1, so f of 0 is 1. Now another important thing, the interval is not given. You will observe in which interval we have to calculate that root, that is not given. So generally the root lies near to the 0, so you have to calculate f of 0, f of 1, f of 2, and so on. And in between you will get two nearest integer where fx changes its sign. So here it is observed f of 0 is 1, f of 1 is a negative. Are you getting? F of 1 is a negative there. Now f of 0 is positive, f of 1 is a negative, so we say the root is in between 0 and 1. Suppose f of 0 is positive, f of 1 is also positive, and f of 2 is negative. Then we take the root is in between 1 and 2 then. Okay, that way. Are you getting? Are you getting this point?
So can you repeat that, sir?
Yes, sir.
Just a minute. Whenever the interval is not given and fx is with us, what you have to do is just calculate f of 0, calculate f of 1, calculate f of 2, and so on. In this case, f of 0 is 1, which is a greater than 0. F of 1 is a minus 2.17, which is less than 0. Whenever fx is positive and negative, we'll say the root is in between them only. Okay, so right now the root is in between 0 and 1. But by chance, suppose f of 1 you get as a positive, and suppose f of 2 is a negative. In that case, you have to say the root is in between 1 and 2. Okay, so the root is never integer. The root is never integer, because if integer root is there, it can be find out by observation only. By observation only, because if you have the equation like this, suppose I give the equation x cube minus 1 equal to 0. Find the root of x cube minus 1 equal to 0. Just by observation, we can say x equal to 1 is root. X is equal to 1 is root. So such examples are never in the numerical methods here. So only these equations whose roots are in fraction, generally we are calculating with these methods. So in this case, we calculate f of 0, f of 1, f of 2, and so on. And whenever the fx changes its sign, positive to negative, the root is in between them. That's one only. Once you get that interval now 0 and 1, you have to just make a table, either make a table or you can do in the detailed way like this, either in the detailed way, or you can write all these things in the table form like this also, So we are going to stop it here, but before we stop, what I want from you, this question number 2, do it in a table form, complete it in table form, do your own calculation. Okay, do the calculation there, and if you have the doubts, you can ask me in the next session also. Practice this question number 1, this example 1, example 2, okay, on a paper, because when you do yourself on paper, then only you will understand it. Otherwise you think, yes, it is very simple, but at the time of exam you can't do this. Okay, so how to convert in radian? We don't have to convert anything to the radian. You have to just switch to the radian mode of your calculator. On a calculator, just press mode button, and you will get RAD. There is radian mode there. Is it clear? Okay. Yes, the difference between regular falsi and bisection, the difference is only the formula. There is a different formulas to for a replacement or reducing the interval. In bisection method, the interval straightforward reduced by half every time and continued. But by regular falsi, the interval is reduced by that formula only, second formula. X e raised to x minus cos x or cos x minus x e raised to x. Both are correct. Yeah, Sahitya. Both are correct. Only the problem is then when my f of 0 is positive, your f of 0 is negative. That is okay. That is okay. Site, you are correct there. That well is also possible. Means fx can be taken as a cos x minus x e raised to x, or x e raised to x minus cos x. Both way. Answer will remain same. Okay. So I think both the CRs. Any absent is there? You can tell me how to change from radian to normal. Now the question is how to convert from radian to the normal mode. So you have to you have to press mode again. I don't have a calculator with me right now.
So shift mode
Yes,
and press 3.
correct. Shift mode and press 3. Correct. It will clear all modes there. Very good. It's reset all, I think.
Yes, sir, reset.
Okay, site 67 is absent. Okay, this is a IMU ID only.